This video, we're going to show you how to do the heating curve of a material based on data. And the next video will show you how to do the cooling curve. You can do both graphs on the same piece of paper. So first of all, you take your graph paper and you copy out this title. Heating and cooling curves of an unknown substance. Then you can take a ruler and with a pencil, nice sharp pencil, you're going to label or darken the y-axis and then darken the x-axis. And then we have to label both of these. So we have to say this axis is temperature in degrees Celsius. And if it's hard to squeeze it in, often we abbreviate it to temp. And across the bottom, the time is going to be in minutes, M-I-N. It's our abbreviation for minutes. And then we have to try to set things up to be convenient. And what we've decided is every 2 squares equals 1 minute, or every 1 square over equals half a minute. And that will be convenient because we recorded the time, the temperature, every half minute. Now going up the side, we're going to try to fit our data, and we start around room temperature 20, and we know we're probably not going to go much higher than 60. If you are getting higher than 60, that's fine. We may not include some of those data points. Now here is the data that I have, and it's completely garbage data that we're just using to show how to do a graph. Your data, of course, is going to be better than this. This video is just showing you how you plot the data. And it's a bit like a game of Battleship. How far over, how far up do we go before we try to sink someone's battleship? So here it says the time is 0. Here's time 0. It happens to be on the green line. And it says 20.1. Now I find it hard to draw with this. I'll do my best. But I'm putting a dot around 20.1, just a bit above the 20. At half a minute is 28.8. So I go over to half a minute. 25, 26, 27, 28.8. And I try to put in a dot like that. Sometimes people put in X's. At 1 minute, it's 34, so I go over one more line. So here is, okay, 33, 1, 2, 2, 3, 3, 34, right on the dot. So I put a dot right on the dot, which almost makes sense. 1/2, it's 39.5. So there, let's see, 5, 6, 7, 38, 39. And we said it's 39.5, so halfway between 39 and 40, I put a dot. I go over one line, 2 minutes, I'm at 42.7. So there's 42.7. And then I'm at 43.4. And I'm doing this by eye. Then I'm at 43.5. And 43.5. And then 44.1. And 44.2, just slightly higher. And 44.0. Don't be alarmed if it goes down a bit. That often happens if you're heating things carefully. 43.9, 43.7, 44.1. Terrible dot there. Another 44.1, 44.3, and boom, and boom, 44.3, and 44.7 there, and then a 48.7. It starts to climb again, and 5, 6, 7, 8. There's 48.7, and then 55.8, and I put in a dot around there. Now what I'm really interested of this whole graph is the flat part. That's called a plateau. That's where the change of state happens. That's where I get my melting point. Now it's hard for me to draw with this thing. I'm going to do my best. It may not be perfect. A lot easier for you to draw with your pencil. And all we're going to do in this graph is connect the dots. In science, we don't always do connect the dot graphs, but this is a case where we're going to do our best to connect those dots. Boom, 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 boom. And I go up to my final dot like that. Right at the end of it, I'm going to write in, and you will do this, I write in heating curve. And hopefully your printing is better than mine on this. So there's heating curve. It's important to do all this because we're going to make more dots for the cooling curve and we don't want to mix them up. So sometimes people use different color and whatnot. Now the other thing we care about, and I'm going to change the color here if possible. So I'm going to use a green line here. And right in here, I take a ruler, and I don't have a ruler for this. And what I would do is I trace a line from there, and then I write down M and P. And MP stands for melting point. I now have the melting point. That's going to be one of the answers to the question. The point means the temperature at which it melts, so according to my lousy data, it's 44. And I'll tell you right now, this is definitely not correct data. So that's the heating curve. The next video, we're going to show the cooling curve where we start at high temperature and it drops. And we'll see how that turns out. But this is how you do the graph.